Hello viewers, in today's session we are going to discuss an important problem from application of derivatives, and here we are going to discuss this problem where we have to prove that the function f of x, that is equal to 2x minus sine square x, is an increasing function for all values of x belonging to the set of real numbers. So now to prove that this function is an increasing function, let us quickly see the definition of an increasing function in terms of derivatives. Suppose we have a function, say y is equal to f of x, which is defined in some domain D, right? Now, if the derivative of this function y is equal to f of x, that is f prime of x, is greater than 0 for all values of x belonging to the domain, then the function is said to be an increasing function, right? So here f of x is said to be an increasing function if the derivative, that is f prime of x, is always a positive quantity for all values of x belonging to the domain. So here f prime of x can also be written as dy over dx, right? So here we'll use this definition to prove that this function is an increasing function for all values of x belonging to R. So here we can easily see that the domain of this function is the set of all real numbers. So here the domain is R, right? Now let us differentiate this function with respect to x. So f prime of x is given by d by dx of 2x, and then we have d by dx of sine square x. Now f prime of x is given by 2 times 1. The derivative of x with respect to x is 1, and here we have the derivative of sine square x as 2 sine x, and then by chain rule the derivative of sine x is cosine x. So now we have f prime of x is equal to 2 minus 2 sine x cos x is sine 2x. So this is the double angle formula for sine 2x, because we know sine 2 theta is 2 sine theta cosine theta. So now this is the expression for the derivative of the function f of x. So now let us make use of some concept from trigonometry. Now see, sine 2 theta, sine 2 theta is always going to be greater than or equal to -1, but less than or equal to +1, right? Because we know that the range of sine function is from -1 to 1. So here we have sine 2x. Now the value of sine 2x is greater than or equal to -1, but less than or equal to +1, right? So let us use this inequality to prove that this function f of x is an increasing function. So let us multiply this inequality throughout by -1. So here we have +1, and the direction of the inequality get reversed. So here we have minus sine 2x, and here we have -1, right? So now here we have 2 minus sine 2x. So to get this expression, let us add 2 throughout, right? So adding 2 throughout in this inequality, we have here 2 plus 1. Here we have 2 minus sine 2x, and here we have -1 plus 2. So 2 plus 1 is 3, and here we have 2 minus sine 2x can be replaced by f prime of x, and here we have 2 minus 1 is equal to 1. So we can also write this inequality like this, that is f prime of x is greater than or equal to 1, but it is less than or equal to 3. So now from this inequality, we can easily conclude that the derivative, that is f prime of x, is equal to 1 or equal to 3, and it lies in the interval that is 1 to 3, where both these endpoints are included, right? And f prime of x is always going to be positive, because here the value of f prime of x lies in this interval, that is from positive 1 to positive 3, for all values of x belonging to R, right? So f prime of x is a positive quantity for all values of x belonging to the set of real numbers, because f prime of x has the value lying between 1 and 3, and both these numbers are positive, right? So we can now write here f prime of x is always greater than 0 for all x belonging to R, right? So from the definition of increasing function, f prime of x should be greater than 0 for all x belonging to the domain. So here we have proved that the derivative is always a positive quantity for all x belonging to R. Hence we can say that this function is an increasing function for all x belonging to R.